Hello friends, welcome to the channel Physics by IITians.
Hello friends, in this video lecture we shall discuss about some special functions in mathematical physics, and this video lecture will be very much important for your upcoming NET examination. So please watch this video up to the end. Okay, so let's start. So here we shall discuss about first the Legendre differential equation. What you have to remember here, you have to remember the differential form of Legendre's differential equation. This is 1 minus x square d2y dx2 minus 2x into dy dx plus n into n plus 1 y equals to 0. So here you have to remember this. This is very important form, okay? So you can write it also in this form, that is d dx of 1 minus x square dy dx plus n into n plus 1 y equals to 0, where n equals to 0, 1, 2, 3 integer values. So x equals to plus minus 1 are the singular points here, because at this point it will show the singularity, and x equals to 0 is the ordinary point of the differential equation. So what will be the solution of this second order differential equation? It will have two solutions. The first solution will have the form this one, and the second solution will have the form this one. Do you have to remember these formulas? Actually not, but if you want to remember, then you can. That there is no problem. So the Rodrick formula for the Legendre polynomial is Pnx. If we denote it, then we can write Pn of x equals to 1 by 2 to the power n factorial dn dxn x square minus 1 whole to the power n. You should remember these formulas for P naught of x, P1x, P2x, P3x. Okay, so please remember P naught x equals to 1, P1x equals to x, P2x equals to half of 3x square minus 1, P3x equals to half of 5x cube minus 3x. So these are the important properties which you must know about the Legendre polynomial, that is Pn at 1 is equals to 1. Pn at minus 1 is equals to minus 1 to the power n. Pn of x is even if n is even. Pn of x is odd if n is odd. And Pn of minus x equals to minus 1 to the power n Pn of x. And the generating function of Legendre polynomial is 1 minus 2xz plus z square whole to the power half. It is the Legendre generating function for the Legendre polynomial, or it can be written as sum of n equals to 0 to infinite z to the power n Pnx, and this coefficient of z, the expansion of the generating function, is the Legendre polynomial of order n, and they should satisfy a very important property that is called orthogonal properties, and it is the most important properties for your problems also. The orthogonal properties, what is that? Just like quantum mechanics, the two state function or wave function will be orthogonal to each other if their scalar product is delta function. So here also the same. Suppose the Pm of x and Pn of x are the two polynomials, and if you integrate it from minus 1 to plus 1, Pm of x, Pn of x dx equals to 2 by n plus 1 delta mn. So delta mn is the Kronecker delta, and it will be only 1 when m equals to n. Otherwise, if m is not equals to n, Kronecker delta function will be 0. And the recurrence relation for Pn of x is nPn equals to 2n minus 1 xPn minus 1 minus n minus 1 Pn minus 2. nPn equals to xPn prime minus Pn minus 1 prime. 2n plus 1 Pn equals to Pn plus 1 prime minus Pn minus 1 prime. n plus 1 Pn equals to Pn plus 1 prime minus Pn prime. 1 minus x square Pn prime equals to n into Pn minus 1 minus xPn. 1 minus x square of Pn prime equals to n plus 1 into xPn minus Pn plus 1. So express, suppose you get a question like this. So express 4x cube plus 6x square plus 7x plus 2 in terms of Legendre polynomials. So you can write this term, that is 4x square plus 6x square, 4x cube plus 6x square plus 7x plus 2 as equals to a cube a3p3x plus a2p2x plus a1p1x plus a0 p0 x. So here you have to put the value for p3, p2, p1, p0. So put the values of p3 as 5x cube minus 3x divided by 2, p2 as 3x square minus 1 divided by 2, and p1 as x and p0 x as 1. So compare these coefficients with of x cube. So this term that is a cube, you should compare with the coefficient of this term, that is, so it will give this particular term will give a cube equals to, or sorry, a3 equals to 8 by 5. Similarly, compare the coefficient of x square. You will get a2 equals to 4. Compare the coefficient of x. You will get look here, you have to just, I think you understand that what we are doing here. Look here, the coefficient of x cube here is a3 5 divided by 2, and here the coefficient of x cube is 4. So a5 divided by 2, it should be equal to 4. Similarly, if you compare this square term, that is a2 into 3 divided by 2, it should be equal to 6. Means 3a2 by 2 equals to 6. If we similarly we can compare the x term here, a cube a3 by 2 and here a1. So minus of 3a3 by 2 plus of a1 equals to 7. So it will give you a1 equals to 47 by 5. Similarly, compare the coefficient of x naught or x to the power 0. So it will give you the term that is minus a2 by 2 plus a0 equals to 2, which gives a0 equals to 4. Okay. So therefore, you can write this term for equation, that is 4x cube plus 6x square plus 7x plus 2 equals to 8 by 5 p3x plus 4 p2x plus 47 by 5 p1x plus 4 p0x. Suppose you can utilize another kind of questions, utilize another property. So show that integration of minus 1 to plus 1 x square pn plus 1 pn minus 1 dx equals to 2n into n plus 1 divided by 2n minus 1, 2n plus 1, 2n plus 3. You have to use this relation, that is 2n plus 1 equals to xpn, that is pn plus 1 into n plus 1 plus n into pn minus 1. So put this n plus 1 in place of n, you will get this one, and put this n minus 1 in place of n, you will get this formula. And then just simplify it. Okay. And you have to remember this one is a very important formula for the recurrence relation for the Legendre polynomial, that is Pn of minus x equals to minus 1 to the power n Pn x. So I have already told you. So here we got up to this one. So now the question is integration over minus 1 to 1 x square Pn plus 1 Pn minus 1 dx. Okay. So we know Pn plus 1, we know Pn minus 1, and we only have to put this formula and integrate. So after integration, you get this one. Actually, these problems are important, but the net problem I will actually discuss. The problem you will face, I shall discuss at the end. Okay. So let us go to another special differential equation, that is Bessel differential equation. And you should remember the form of Bessel differential equation, that is x square d2y dx2 plus x dy dx plus x square minus n square y equals to 0. And x equals to 0 is a regular singular point of the Bessel differential equation. So what is the form of Bessel function? Jnx, that is equals to a0. This is the solution. So a0 sum of r equals to 0 to infinite minus 1 to the power r divided by r factorial n plus r factorial x by 2 whole to the power n plus 2r, where a0 is equals to 1 by 2 to the power n gamma n plus 1. So if n equals to 0, j in x will become j naught x, and the formula will become like this, and we will get this formula. Okay, just expansion of this formula, nothing more than that. Hope you understand. So if we put n equals to 1, then we will get j1x. If we put n equals to 2, we will get j2x. And if we plot the different j0, j1 with respect to x, then we will get this kind of graph, okay, or this kind of curve. So what are the properties of Bessel function? Bessel functions are oscillatory function with a varying period and decreasing amplitude. Look here, these are the oscillatory, but they are not the periodic kind of thing. They are varying periodicity they have, and also they are having this decreasing amplitude. Look here, the amplitude here is much larger than the amplitude here. Also, the amplitude here is much larger than amplitude here. Jnx is an even function, means when n is even, and Jnx is an odd function when n is odd. And J0x has a nodes at x equals to 2.4048, 5.5201, and so on. So nodes means the function value will become 0. So J0, if we plot this J0 like this way, we will get the plot. And here the zeroth value for the J0 at x equals to 2.4048. Okay, and the second node is 5.5201. And similarly, J1, we get the first node as x equals to 3.8317, and the second for this J1 node is 7.015. If we find out the value of j half and j minus half, we get these two values, that j half of x equals to root 2 by pi x sin x, and j minus half of x equals to root 2 by pi x cos x. And what will be the generating function? The generating function for the Bessel function is, let me mute the phone. Okay. So the generating function of Bessel function is this one, that is e to the power x by 2 z minus 1 by z equals to sum of n equals to minus infinite to plus infinite z to the power n jn x. So the coefficient of z to the power n is the expansion of the generating function, is the Bessel function of order 1. And you have to remember this orthogonality condition. Okay, so integration of, earlier it was minus 1 to plus 1, here 0 to 1 x jn alpha x jn beta x dx equals to delta alpha beta by 2 jn plus 1 alpha whole square. The recurrence relations for the Bessel function is x jn prime x n jn minus x jn plus 1, x jn prime equals to minus n jn x jn minus 1, 2 jn prime equals to jn minus 1 minus jn plus 1, 2n jn equals to x into jn minus 1 plus jn plus 1, ddx of x to the power minus n jn equals to minus x to the power minus n jn plus 1, ddx of x to the power n jn equals to x to the power n into jn minus 1. Okay, so suppose there is a question that show that ddx of jn square x plus jn plus 1 square x equals to 2 into n by x jn square x plus minus n plus 1 by x jn plus 1 square x. What will be that? So you have to find out the differentiation with respect to x of this function. So find first the normal differentiated, that is 2 into jn into d dx of jn, that is jn prime, 2 into jn plus 1 into ddx of jn plus 1, that is jn plus 1 prime. Now put this formula, that is jn prime, which is equals to minus n by x jn x jn minus 1. Okay, and you find out this result. You can have different like this kind of formula. You should remember if you get, otherwise it's okay. Okay, because you have to remember some crucial formulas which are very important for the upcoming examination. So I will tell you which one to remember, which will one not to remember, or you can remember, you cannot. It also possible that you forget that one. Okay, so form, but I repeat, the form of the differential equation you must remember. You should not forget about the form of the differential equations. So you should also know the Hermite differential equation. the form of the Hermite differential equation, that is d2y dx2 minus 2x into dy dx plus 2ny equals to 0, where n equals to 0, 1 and x equals to 0 is an ordinary point of Hermite differential equation. And the solution of the Hermite differential equation, if we write this h and x, that will become sum over r equals to 0 to p minus 1 to the power r n factorial 2x to the power n minus 2r divided by r factorial n minus 2r factorial, where p equals to n by 2 for n equals to even, and for n equals to odd it will become n minus 1 by 2. The Rodrick formula for h and x is h naught 1 equals to h naught x equals to 1, h1 x equals to 2x, h2x equals to 4x square minus 2, h3x equals to 8x cube minus 12x, h4x equals to 16x to the power 4 minus 48x square plus 12. So these are the Hermite polynomial of order 0, 1, 2, 3, 4 and so on. We can, if you just remember this formula, if you don't remember all the values, if you only remember this formula, you can put 0 in place of n, you get h naught x. You can put 1 in place of n, you will get n1 or h1. Similarly, you can get higher orders. Okay. So the Hermite polynomial of different order differ from the Legendre polynomial with respect to the coefficient. Look here, having the coefficients are different. So the nature of the graphs of h and x and the Legendre polynomial will be same. Although the coefficients are different, but the nature of the graph should be same, because they have similarity in their polynomials or their form of the polynomials. What will be the generating function? Generating function is e to the power 2zx minus z square, that is equals to n equals to sum of n equals to 0 to infinite hn of x by n factorial z to the power n. Orthogonality property, you should also remember this one, that hn also have orthogonality property, means if you integrate over minus infinite to plus infinite e to the power minus x square hnx hmx dx, you will get a delta function. And delta function, that is delta mn, will be only 1 when m equals to n, otherwise it will be 0. And other recurrence relations for the hnx, that is hn prime x equals to 2n hn minus 1x, 2x hnx equals to 2n hn minus 1x plus hn plus 1x, hn prime x equals to 2x hnx minus hn plus 1x, hn prime x equals minus 2x hn prime x plus 2n hn x equals to 0, hn of minus x equals to minus 1 to the power n hn x. Another formula differential equation, that is Logar differential equation. It has the form x into d2y dx2 plus 1 minus x into dy dx plus ny equals to 0. X equals to 0 is a regular singular point of the Logar differential equation. And the solution, that is ln x, has the form sum of minus 1 to the power r n factorial x to the power r divided by r factorial whole square n minus r factorial. Rodrick formula for ln like this way, and you can find out L naught, L1, L2, L3, putting this in this formula ln x. Okay, and the generating function for the Logar polynomial is this one, that is e to the power minus xz by 1 minus z divided by 1 minus z equals to sum of n equals to 0 to infinite z to the power n ln x. And orthogonality property of the Logar polynomial is integration over 0 to infinite e to the power minus x ln x lmx dx equals to delta mn. So the next, this is the most important thing that we shall discuss here, the previous year questions that has come in this chapter. So here, look here, this is CSIR June 2011. The question is, let P and X, where P n is n equals to 0, 1, 2, be polynomial of order n with real coefficients defined in the interval 2 to 4. That is, n lies between 2 to 4. Now, if integration over 2 to 4, Pmx, Pnx dx equals to delta mn, then which one is the correct value for P0 and P1? So first you can check whether this Pn, P0, P1 are normalized or not. So for the condition of normalization, you have to check that. Suppose I am checking the condition for normalization for P0x. Okay, so I have to check whether this product or whether this integration is 1 or not. just like the you can analogically you can think that is analogy to the with the quantum mechanics, that whenever we are finding out the normalization, we are checking out the normalization of wave function, we actually this thing, right? And we integrate over that particular region. So that is here also. So integrate over 2 to 4, and this is the normalization constant n square into that function, that is wave function. Here it is p naught x, and this should be mod square into dx, and it should be 1. So we get n equals to 1 by root 2. So normalized p naught x is 1 by root 2. So first find out that whenever there is p naught x value is 1 by root 2, these options may be correct option. So look here, option C is totally discarded because this is not normalized. Now find out the orthogonality condition. For orthogonality condition, you have to check these two different functions product, and you have to integrate over 2 to 4 p naught x p1x dx, and it should be equals to 0. So you have to check, suppose you take one option like option D, and you check p naught and p1 whether they are into product and integrate it whether it is 0 or not. So p naught here is given as 1 by root 2, and p1 is given as root 3 by 2, 3 minus x. So p naught and p1 you integrate, and you will get the product is 0. So option C here, so option D is the correct answer. So whatever you have to do here, you don't have to remember any other formula. Only this is the term here, that is the integration over 2 to 4 pmx pnx dx equals to delta mn. So it should, this p naught p1 satisfy this condition. If m equals to n, then the product should be, the integration should be 1. If m is not equals to n, the integration should be 0. And that's all for answering this question. Okay, hopefully you understand. Let's come to another question, and this question is very much important for CSIR-NET, TIFR and GATE JEST examination. So please understand this question. The question is the generating function f of x naught equals to sum of n equals to 0 to infinite pnx t to the power n for Legendre polynomial. This pnx is f of xt is equals to, that is 1 minus 2xt plus t square whole to the power minus half. The value of p3 at minus 1 is how much? That is 5 by 2, 3 by 2, 1 or minus 1. So first of all, you can write this f of xt as sum of n equals to 0 to infinite pnx t to the power n, and the value of this is 1 minus 2xt plus t square whole to the power minus half as given in the question. Now look here, they are asking you to find out the value of p3 for minus 1. So what you have to do here, for the x value, you put x equals to minus 1 in this above equation. So you will get 1 plus 2t, because 2 into minus 1 will become minus 2 into minus 1 will become plus 2. So plus 2t plus t square whole to the power minus half, and it is sum of n equals to 0 to infinite pn of minus 1 in place of x into t to the power n. So if this term can be written as 1 plus 2t plus t square can be written as 1 plus t whole square. So 1 plus t whole square means 1 plus t whole to the power square into minus 1 by 2, so whole to the power minus 1. So you can expand this, that is 1 plus t whole to the power minus 1 as 1 minus t plus t square minus t cube plus t to the power 4 and so on. So it can be, now you can compare with this value, that is n equals to 0 to infinite pn minus 1 into t to the power n. So for here p3 of minus 1. So compare this to, you will get p3 of minus 1 as minus 1. Okay. So this p3 will be this t cube. Okay. So p3 of minus 1 into t cube. So here this coefficient is how much? Minus 1. So p3 of minus 1 will become minus 1. Similarly, if the same question, if they ask you what is the p2 of minus 1, so you will get plus 1. What is the p4 of minus 1? You will get the plus 1. So what you have done here, you just put the value in place of x, and then you expand the series and you compare the two coefficients. That's all. So correct answer is option D. Okay. So let us take this kind of questions, some more. Look here, this is another question that the graph of the function f of x shown is described by the Bessel function cos x, e to the power x cos x, e to the power minus x cos x, or cos x by x. Look here, this is function is the Bessel function for J0 x. Okay, so we have already seen this. So no doubt the option A is the correct answer. So the different other terms, that is cos x, e to the power minus x cos x by x, we have already done the graph videos. 3 or 4 videos are already there. Please watch those graph videos. If you have any confusion related to graph, it will be clear. Okay, I guarantee that any kind of confusion about the graph, it will be clear to you. So let us come back. This question is another question that has come June 2013. So given that sum of n equals to 0 to infinite h n x to the power n by n factorial equals to e to the power minus t square plus 2tx, the value of h naught 0 is how much? Similarly, just the same thing you have to do here. First of all, write sum of n equals to 0 to infinite h n x to the power n by n factorial equals to e to the power minus t square plus 2tx. Now, what is the point that you want to find out the value, that is x equals to 0. So put x equals to 0 in this above equation. So you will get n equals to 0 to infinite h n 0 to the power n by n factorial equals to e to the power minus t square. 2tx term will be 0. So e to the power minus t square, you can expand it by 1 minus t square plus t to the power 4 by factorial 2 minus t to the power 6 by factorial 3 and so on. So you need to find out the coefficient of h4 naught. So compare this coefficient of h4 naught. So this one term for this first term, so 0 term, if t to the power 0, it will become 1, so it will become 1. T to the power 1, it will become t, so there is no term of t, it should be 0. And if h naught here, h4, so t to the power 4 term is necessary. So t to the power 4 term, the coefficient of t to the power 4 is 1 by 2 factorial. So the answer is 1 by 2 factorial. So h4 naught by 4 factorial equals to 1 by 2 factorial. Here h4 0 divided by 4 factorial. So it will become 1 by 2 factorial. So h4 0 at point 0 x equals to 0 is 12. So correct answer is option A. So this kind of questions are very much important. So look here, this is another question, the same kind of question, that is given sum of n equals to 0 to infinite p n x t to the power n equals to 1 minus 2xt plus t square whole to the power minus half for t less than 1. The value of p5 of minus 1 is how much? So I think this is enough for you to understand how to do this kind of problems, and this is your homework, that p5 of minus 1 is minus 1. So correct answer is D. So I am not showing you the answer again. So please do this math and solve this kind of questions. This kind of questions are very important. Hopefully this video will be helpful for you. If we find it helpful, please share with your friends. Do subscribe our channel, like our videos. You can join our test series. For that, you just join our Telegram channel, that is Physics by IITians, or contact us individually on Telegram. Thank you so much.